Dr. President Choi, or should I address you, Christine, fellow members of AAM and Hong Kong IA. I'm glad to launch this 2020 Hong Kong IA AAM joint seminar series. Due to the COVID-19 outbreak, unlike in previous years, we have to conduct the series online instead of staging on site in Macau or in Hong Kong, respectively. Looking from a positive perspective, it's true that even the pandemic cannot deter us from taking the joint efforts of offering exchange of opportunities for our members. However, the future new normal of going online might offer more means to help enhance and strengthen the future communication between Hong Kong IA and AAM. Besides sharing the values and the visions of the SAM profession, Hong Kong IA and AAM do possess quite some commonness that makes our exchanges more practical and fruitful, such as both Hong Kong and Macau are dominated by Chinese culture and community, yet with the fields of East and West due to our historical background. Both cities with architectures of heritage status, while diverse style of modern architecture has sprung up in recent years, both facing the challenge of growing population amidst limited lands for development. This joint CPD activities of Hong Kong IA and AAM since 2018 does cover quite some interesting yet common issue for architecture in both cities. Topics covered so far including, I recall that started from 2018, waterfront concept design, flood control facility design, green architecture, revitalization of heritage buildings. Last year, members of Hong Kong IA and AAM also conduct joint site visit in both places. Having visited in Macau, the Cinema Passion, Panther-Light Watch House and Library. In Hong Kong, we visit the Tai Kwun Compound, MIC Display Center of CIC, and CITAC Center. The focus of this year joint seminar is on planning, as Yvonne just mentioned, including the latest planning trend and technologies, city and community management, etc. Hong Kong IA side is to kick off the series with the first two seminars. The first one, to start with Dr. Chong of Arab tonight. Thanks for that. And the second one, Mr. Ng Dak Wah from our planning department in the next seminar by the end of October. Due to the COVID-19, many Hong Kong IA meeting and CPD events have to postpone or go online, just like this one. Yet, instead of just waiting for the outbreak to go, we have been working in collaboration with related institutes such as the AAM, and also recently we have conducted a joint institute, joint professional institute in the hope of taking the reference of COVID-19 for the betterment of the community. And I hope with this series, new idea will also comes up and enlighten our member and to look into the planning and how to benefit the community. With that, we will be more than happy to join hands with AAM in future for more meaningful CPD event. With this remark, I look forward to have more fruitful Hong Kong AAM collaboration in future. Thank you. Okay. Thank you, Yvonne.
Yeah. Oh, thank you, Felix. Yeah, and by now we pass to Zoom. Would you pass to AAM President Christine to have an opening speech? Yeah.
Good evening. Good evening, Yvonne, Felix. Hello.
Hi.
Hello, great friends, HKIM members and AAM members. Well, firstly, let me introduce our team from AAM side. We have from from Board of Director, our Vice President, Donna Wu. And we have also Director Jimmy Wadana and myself, Christine, the President of Board of Director. And tonight, as Felix said, is the first series of the HIA crossover AAM CPD webinar series. There will be a total of 4 webinars. The upcoming one from AAM will be on heritage and adaptive reuse, which will promote a bit further down the track. And as also mentioned by Felix, HIA and AAM have been collaborating in many channels throughout the years. And now it's so good to see we've been elevating on a digital platform, allowing more possibilities and engagement with our members. 2020 is a different and challenging year for everyone. Well, we have adapted to the new normal. Also for architecture, there will be a shift and the need to reconsider how buildings and cities should be designed and planned. HIA and AAM, along with Acacia Social Responsibility Committee, is currently now undergoing a COVID-19 task force guideline drafting group, aimed to have a set of framework as design guidelines. And with other 5 committee ongoing working group, knowledge and professional practice is shared across the different Asian Architect Associations. This is a collaborative effort and a good platform, a very good platform for continuous learning. I encourage more architects and all of you can initiate to participate and get involved. And with the recent release of Macau Master Plan draft, it is a very important milestone for Macau's development. Currently, it's gathering comments from the general public for the draft master plan. Following that will be the detailed drafting phase, etc., and detail, and then realization. This initial process will need contribution from our industry profession and providing available comments for the government. AAM will have a members discussion work group in early October and will send out emails for our members soon for your involvement. And tonight's topic is something we have not touched on before, and I trust this will bring a new perspective to our members. Thank you HIA for the arrangement of tonight's topic, and I hope to see a lot more ways of collaboration and information exchange in the future on different platforms, mediums, channel, and possible engagement between our members. Now I look forward to seeing Bruce's presentation for tonight. Thank you.
Thank you, Christine. Yeah. Okay. So before I pass to Bruce, I have a brief introduction to Bruce. So very quick. Yeah. Dr. Bruce is a leader of urban sustainability team in Europe, with focus on formulating strategy and implementation plan on resources efficiency, green infrastructure, and smart resilient cities. Bruce is the skills leader of city resilience and sustainable infrastructure design leader for the region, working on projects from cities, district to community levels in Hong Kong, mainland, and South Asia. He's a Cambridge Overseas Scholar and also research fellow in the Sydney University. He's a recognized expert in smart city, carbon, climate change, resilience, and sustainability fields. Bruce also an active role in Professional Institute, and also, for example, the Smart Green Resilient Framework, which has now been adopted by Hong Kong government. Some recent smart city related projects, for example, like development of common spatial data infrastructure, built environment application platform for the Hong Kong government. So the synopsis for today for Bruce is talking about the digital twin technology. So maybe we pass the the screen to Bruce, like him to introduce more for tonight about the talk.
Hi, Bruce.
Hello, can you hear me?
Yeah.
Yep.
All right, good.
We're passing the screen to you. Yeah.
Yes. May I share the screen now?
Great.
睇到係咪？
Yes, no problem. I don't.
Okay.
係咪我哋呢個？因為佢經。
Okay. Can everybody hear clearly and see the screen? It's okay. Okay. Thanks a lot. Felix and Christine. for your invitation. And I'm glad to join this CPD. I just learned that this is the first time in this year for the seminar, the CPD series. I'm not an architect. By training, I'm an engineer on the mechanical side. But I've been working a lot in my career with planners, with architects, with designers. Because of the projects that we are working on, the company working on, and I also work recently quite a lot on smart city, and because of the trends years ago when we started more or less around 5 to 6 years ago at strategic level in the Euro and also in the UK side, and then and obviously smart city and digital application, and today about the digital twin are now more on the application side. Clients, governments are more concerned about the application implementation and how to realize from concepts to actual something that can be tangible. So today I would like to learn from you and bombard ideas with you by sharing some of the works that I'm working on, and trying to explain a little bit the concept behind, and also through some actual projects that you can pick up a little bit more from the latest trend on, I would say, data platform, data informatics. There are a lot of buzzwords, I would say, around this area. Some people call it data informatics, data analytics, data platform, common platform, etc., etc. So there are a lot of terms that we will go through in this CPD. So bear with me. So on the agenda, in the coming, how many minutes I can have? I think around 45 minutes. I will go through 4 key agenda items. I'll explain to you the overall picture, the concept, what does it mean by common data platform, what does it mean by data analytics, etc., etc. And then I will divide it into 2 parts. The key components is on data. Another key component is how to use the data. So it's on the user cases, on the applications. And the 4th agenda item is on how to implement and realize data related user cases in our actual project. So first, agenda item. So the overall concept, the big picture. So the digital applications or the data application is originated from smart city. So I would like to share with you sort of some kind of standard framework for smart city first, and explain to you where should we position the data. So you see these 4 building blocks of what we normally have, and we need to include in a project. So I call it the building blocks, right, for smart city. So for every project, we need to set out the visions, we need to include the guiding principles, and then under these visions and guiding principles, we need to develop different types of applications underneath. For example, on energy, if we want to achieve the visions of zero carbon, for example. So on the energy side, which is one of the applications, how should we deploy our smart meter for energy? For example, we need to define our visions as walkability, connected and safe district. So we need to have our application on the transport and pedestrian. So we have different disciplines of applications. So we have the application layer, and then underneath the application layer, we have different data. You can imagine there are different systems within different applications, from energy to water to waste to transport to environment to living, etc., etc. There are different classes or categories of applications, and in each class or in each applications, there will be a lot of data generated. And how do we store this data? How do we make use of this data to serve different types of services? Now, so the data will come underneath the applications. And then another issue is that we need to have the ICT infrastructure to support data collection. So now the sensors are everywhere. I'm sure that you heard about a term called IoT, right? Internet of Things. Basically is is the concept of putting sensors in different levels for all different disciplines, and you need to collect all the data, right, from district level to street level and then to building level. So you need to have those ICT telecoms in place to make sure that the sensor data can be systematically and easily and effectively collected and go to the back end to support the overall data management. So let's recap. So now we have the visions on top. So we have the slogan for different types of project. It could be green, it could be wellness, it could be smart, it could be happiness, etc., etc. And then we have different application across disciplines. So you see there are different domains, different disciplines representing from mobility to waste and then to environment to security, etc., etc. So different vertical domains. And come underneath is the bottom part is the horizontal backbone to support, right? To support the data collection, right? So when you collect the data and then you need to collate the data and then store the data and then try to make use of it and then share the data, right? So this is something we call the standard building blocks for the smart city. And then along with these four key building blocks, there are two things that we also need to consider. I call it the governance and delivery process. This is important for each building blocks. For example, the procurement process, how to manage the data, how to share the data, who can own the data, who can use the data, the security and the privacy, etc., etc. So how to control and manage the overall delivery process from the ICT infrastructure to data and then to different application disciplines. And then we also need to take into account the demand from top down and bottom up. So from top down, any government standards, any regulations, any blueprints, any strategies from the corresponding government or national related policy. So we need to appreciate that, as well as we have increasingly concern about the end user experiences, right? The clients usually ask, oh, you do a lot or you recommend a lot. You know, we architect and we engineer, we like to, you know, outline the storyline. We need to have the appropriate recommendations to the client. But we need to have the justification of why we need to provide these and that. So we need to link up with the end user, right? We need to make sure that they're happy with the end result. So that's why we need to, you know, also appreciate and take into account the demand from top down and bottom up. So this is sort of the framework of smart city. And these 6 building blocks are those we usually need to consider from prelim planning level to implementation level. We need to, from stage to stage, we need to take care of all these building blocks. Now, the focus of today, right, is on data layer and application layer. So the data and applications are the core building blocks that we are focusing today. So I'll spend a little bit to explain a little bit more about the data platform first. Now, conventionally, for a typical project, from building level to a district or even to a city level, we used to deal with 3 types of data, right? In a nutshell, we must have CAD, right? We used to have CAD and digitalize all our design through CAD software, right? And then years ago, or well, incrementally, we need to adapt or adopt BIM into our projects, right? So basically it's from 2D digital to 3D digital, right? So CAD and BIM now become a norm or must, right, in our project. And then if the project scale is bigger, covering more surrounding areas, peripheral areas, including road network, and also maybe some urban regeneration project, for instance, that we also need to have the GIS to support the data visualizations, as well as our daily or regular design and planning, etc., etc. So these data are static, right? So I put static data for all these 3 types of data, meaning they won't change very frequently, right? When we have the CAD data, we normally have different versions, but it's not talking about real-time data that we need to take care comparing or in contrast with those sensor data, right? So they are defined as static data. Now this is the old day, I would say, data platform, GIS, BIM, and CAD. But now, increasingly on the data platform side, apart from those three types of data, GIS, BIM, and CAD, they are all static data, as I just mentioned. We have dynamic data from our sensors. So we have IoT sensors, right, ranging from different classes. I mean, disciplines or domains. It can be energy sensors, can be water sensors, waste sensors, etc., etc. CCTV, of course, is another one type of sensors. So there are different types of sensors for different disciplines. They are dynamics data because they are real. I mean, in terms of timing, they're real-time data where we can collect them very frequently right now. So apart from IoT sensors, we also have dynamic data from the social media, right? And then another type of static data that are increasingly useful is from satellite images, drone images, and LiDAR data, and a lot of stock photos. I'll explain why they're also important to our project in the coming slides. But just bear with me that on the data platform, it's not only the conventional GIS, BIM, and CAD. We have more data that we need to deal with. And the client as well, they need to be accountable for the data that are being collected on the site, as well as you can imagine they need to liaise with different teams like BIM, CAD from the design team, GIS probably from the government side, social media from the internet, satellite image, drones image, LiDAR, stock photos, maybe from the client themselves, also from the government, etc., etc. So you can imagine a lot of collaborations, a lot of data types, a lot of coordinations. So that's why that there is a need of a library system, or you can call it a common data platform to store properly these different types of data. And on the other side is we call it application platform. So it's quite easy to understand that when we have the data available, how can we make use of this data to realize different functions under different disciplines, right? The disciplines could be from planning to mobility and then to utilities, building and landscape. So you name it, there could be different types of applications. So the important point here is that we need to have a common data platform and application platform to facilitate both sides, to justify why we need to have the data platform in the first place, why we need to kind of improve or elevate the level of details and the bulk and the volume of the data from conventional data platform to common data platform. With the use of data through applications, then we can probably justify why we need to collect data in the first place, right? So this is kind of a hand-in-hand approach. With the data on the left-hand side, we call it actionable data, meaning the data is not useful, is useful, or can be used, actionable, right? Applicable to those user cases and relevant to the project. So this is the concept as a whole that we tie in both data and the application in a single platform. So you can imagine the parable is that the data side on the left-hand side is just like a supermarket. So at project level for a site, and similarly apply at a district level, at a city level, at a national and global level, basically it's the same. The explanation is the same. On the left side is that we need to have the data. So it's like a supermarket, right? It's a supermarket. So the ingredients are prepared for you, to buy. So you have a purpose to buy something because I'm the chef, right? To cook something exciting, meaningful, So on the right-hand side is basically the use of the raw data for making your cuisine, right? So you can imagine you buy something, you get something from the market, which the ingredients are prepared for you and classified for you. So the supermarket is very tidy, right? Everything is classified. So just like the data is classified by different categories, by different types, by different stages, etc., etc. So it needs to be tidy, right? So that's why we need to have a common platform. We need to have a library to store the data. And then on the other side, we make use of the data, justify the value of the data by making different dishes, right? Different cuisine. So on the right hand side, basically it's a restaurant, is the product, right? Is the testing of all this data. So people may ask why we need to have all these, right? For city government, and then for the client, why we need to have all that. So I think I already explained some of the points. So why we need to have a common data and application platform to take care of both sides of data and applications. So basically here are the key sort of the benefits and the justification of producing or developing this platform. You can put it at site level or district level or even city level. Today we'll spend more time on city level, and also I will cover a little bit on district or project level. So you can see these are the sort of the benefits and the merits of having this platform. Cost saving, and then improve service efficiency. You can imagine there could be a lot of different services riding on the data, right? For example, if you need to route you need to walk and route the district. So through wayfinding system, you need to have quite a lot of information. You need to have the map at the back end. You need to have different sensors to provide weather information, environmental information, and real-time air pollution information, etc., etc. So that's why we need to have all this data in the platform to produce a more efficient service, right? Enhance collaborations between academia, between government and professionals, etc., etc. And more importantly, to facilitate in-depth analysis. So we talk about big data. So without collection or collation of this data, how can we achieve the analysis, right? So that's why the facility management and also the operational team, they're always concerned about whether we can have integrated building management systems to collect, different systems in real time, and then with this data, they can understand the health, understand the conditions, real time of the system, and then do more preventive maintenance, etc., etc. And of course, to further spur applications on AI and machine learning. Right now, from a global perspective, as I mentioned, I would start by talking a little bit more from a macro view, talking about the city's government, what they are now doing and considering. Now you can see, I keep mentioning two dimensions. One is the data dimension, another is the applications dimensions. And of course, there's differences between the level of details on both dimensions. Here you can see the y-axis and x-axis. The y-axis is the data. So on digital 2D, of course, is the most sort of the bottom line, basic baseline element that we need to have for a project. So from digital 2D like CAD, and then moving on to conventional 3D model like BIM, right? Like mesh model at city level. I'll explain what they are, right, in a minute. So we have a conventional 3D model. In Hong Kong case, we already have a 3D model for more than 8 to 9 years. We planning department and lands department, they have produced 3D mesh model, right, like our Google Map in 3D since 2011, 2012. So basically, we have all the territorial level 3D model, but we just call it conventional, right? Now we are moving forward to produce enhanced 3D model, and I'll explain what does it mean by enhanced version comparing to conventional. But you see there are a lot of dots here representing the government, what they're doing and what they're aiming for, of course, is this part. Now representing the best or enhanced 3D models on the y-axis, and on the x-axis is about the applications. Depends on the depth, right, and the level of details of what you are using or harnessing the data. So from the bottom case is our digital visualization. So basically it's the viewing of all this data, 2D, 3D data visualization. I can see it, right? I can see it, I can appreciate the outlook of a city, of a district, etc., etc. And then moving on to individual applications. As I mentioned, by making use of different data, the different surfaces, different applications, individual. right? For example, transport department, they use some transport data to do their own applications. And similarly, other departments or other teams, if the case is within a project, right? So different design team, they have different individual applications, right? Now, if we are moving towards a more detailed understanding of the data, as I mentioned, by making use more more sophisticated applications through AI or machine learning, and integrated and interconnected kind of applications, that would be sort of the ultimate aim. So you can see in China, basically, in terms of producing the 3D model, they are moving quite fast, right? Because they spend quite a lot of resources to produce city-level 3D model, right? And then in Hong Kong, the government from Landsd and Lands Department and Planning Department, basically they're doing hand in hand by pushing more applications and liaising with different departments to realize different types of applications through using the 3D data, right? And also different types of data in a common data platform. So you can see, I explain now that, for example, in Berlin, in the Euro side, they already, from the government side, produced 3D models, 3D data models, 3D city model for public use. So basically, academia and professionals can make use of the 3D model and enhance the 3D model, right, to do different applications. I cannot spend too much time explaining the details here, but you can see the hierarchy that, for example, another European city, Finland, in Helsinki, they have sort of a platform called CityGML, right? This is a standard type of city-level information format. It's called CityGML, and then they have this platform to share the data from GIS and then IFC, basically another type of building level BIM model to basically to facilitate different types of applications, right? And I explain in the coming slides the model from city governments and also in project level. And you can see the virtual Singapore. The Singapore government also have the city model, as well as they make use of this model to collaborate with different academia and also professionals and also different government departments. And likewise, in Hong Kong, I just used this slide before, like the supermarket and the restaurant on both sides. In Hong Kong, the Lands Department, they have already set up what we call a CSDI portal, Common Spatial Data Infrastructure Portal, representing the data, right, the geodata store on the one side. On the other side is that they have set up another platform to stimulate and to facilitate the applications or production of applications by making use of the geodata. So you can see both the government, they are quite concerned data and applications and try to, under the umbrella of smart city, try to stimulate more data collection as well as the data applications. So I'll explain a little bit about the data. So this is the first part. I just sort of give you an overview of what the government is doing, and then the data side and application side. Now the data side. So we need to understand from data perspective, there are different sort of classifications. You can classify it by type, by level, by stage, or by level of detail. I go through it very quickly because they are quite dry. Just let you know the concept. Static data, dynamics data, I explained to you. Dynamics means real-time data, so you can get the real-time data from the IoT sensors, comparing with those static data that doesn't change very often, right? And then the second classification is by level. So from city level to community level to building level. So you may be aware that, well, in city level, more relevant data is on GIS. Through GIS, we have the transport, utilities, climate, demographics, and land use. On community-based data, we more often have the pedestrian movement data, air quality, or energy or safety data. Building level, usually we need to have a BIM, CAD, building management system, IAQ, or wellness data within the periphery or within the building, right? So we have different levels of data. The data sometimes we classify it by stage. So for example, we have BIM from, this is sort of standard kind of staging of using BIM from 0 to 5, and then from inception stage, prelim planning, and then planning, and then detailed planning, and then design from PD, SD, and DD, and then to construction, and then project completion, and starting from operation, and then we can go back to stage 0. So basically by stage, right? And then by level of details, so you may have heard about the LOD, you know, from BIM, right? This is a terminology for BIM as well as for city data. So LOD 0 basically is the site area, and then to the building blocks, and then we have more detail of the roof, and then extra detail of the roof, more elements shown in like the facade and the roof components, and then LOD 4 basically including interior elements within the buildings, right? And then also by categories. You know, you can imagine from a city perspective, you have different types of data from buildings, infrastructure, roads, networks, bridges, etc., vegetation, and then sites, and water body, and also terrain, landscape, etc. So let's look at, now through all the data, we can build up the digital twin, right? So at building and infrastructure level, you can take a look at, well, this is the building level BIM model. I think you're familiar with it because you use it in your daily project, I believe. And you can take a look at the digital twin that we are working for infrastructure project. So this is the BIM model we used for one of the MPL's project in Sha Tin Central Link. Show me a little bit. So you see the BIM model from underground, building piling, and then to the station. And also for the station, within the station, exterior and interior. So basically, this is the digital representation of the station outside and inside by making use of the BIM model, right? Okay, and I assume because the popularity of BIM, so I won't spend too much time to explain BIM, and I assume through your daily works, the BIM, relatively speaking, is more familiar from your side. So I go on to explain at city level what would be the digital twin. So you can just imagine basically it's the 3D of Google Map, but what does it what does it mean, and how does it relate to our applications in planning and design? So you can see here, it basically is a capture of the 3D city model, right, in Hong Kong. And it's more complicated comparing to a building level, infrastructure level by using just BIM because of the complexity of producing the 3D map. Conventionally, we need to make use of helicopter in the old days to capture by making use of cameras to capture different images, and then at the back end to integrate all the images, right, and then create a 3D model. Now, apart from the space, satellite images, and also the aerial images through the helicopters, we can make use of drones, which can fly more frequently to get more data, and we can get the updated version of 3D more frequently. And apart from from the sky, tools, we can also now have the land equipment. We call VMMS, and BMMS is a mobile mapping services through vehicle. So vehicle mobile mapping service and backpack mobile mapping services. So we can make use of the ground level or street level cameras to capture all the images at ground level, at street level, to supplement sky level images. And then through all the data collections by different means, right? We can capture different types of data, and then we integrate all different data from space, from sky and land. Combine all this data to produce the outdoor 3D map, right, with the building envelopes. And on the other side, of course, we can have the indoor scanning through the point cloud. Basically, it's a laser scanning within the building. So we can produce the indoor map or indoor 3D map more accurately, right? And then we can combine both outdoor and indoor. So we can have, if we make use of it for wayfinding, for example, map, we can have seamless experiences between indoor and outdoor. Right, and in China, as I explained earlier, a lot of Chinese cities has already produced the 3D map, talking about 1/3 or 1/4 of the whole city. So like in Beijing, in Chengdu, and in different cities, etc. Also produce the digital map. Enhance the 3D 21 east to current west. The differences object shape from this functional 3D model. Which one is tree? Which one is lamppost? Which one is facade? Which one is building? Because they are all meshed together. So we call it mesh model, right? Everything together, right? You cannot tell the difference. You cannot differentiate. You cannot treat it as individual objects. So you cannot identify or analyze each single object. Now this is sort of, we call it conventional 3D mesh model. Now, the enhanced 3D model is that because of the available images that we can take at ground level. So remember the car, the Google, you can just select the Google car, right? The vehicle mobile mapping service, and also the backpack. So you can have your photos taken at the ground level. You can take millions of photos. And then with all these photos, we can have much better, right? Presentation and visualization at street level. Now, this is not the important point. It's not just only visualization, but the important point is everything you see here can be treated as an individual object. Now, this is the most important point, because here, right, the pillar box is an object. The lamppost, the traffic light, each individual tree, the facade, the windows, the building, rooftop, etc., we can divide it into different objects. Now, because of this individual object that can be identified in the 3D model, we can do much more, right, through this available 3D model. For example, we can capture individual tree to analyze the health of individual trees and how it helps shading for pedestrian. Now, here we can also extract different transport information, like how many lampposts, how many traffic lanes, how many how many street furnitures by item, right? And then you can add information for each item, meaning you can have information of information, right? So this is the the most important of this through the back end, because now if you have more free images, then different shop. In the old days, how the types this is for medicine. In the street that I'm going to analyze very quickly, right? So you can have more information captured and extracted through the AI at the back end with the available enhanced 3D models, right? So this is, I let you know, I let you have a quick look of what does it mean by an enhanced 3D model. Like in the old days, this is a view for Guangzhou. You see in the tower, and in the old days, or even in Google Map, you can just compare. You take the same view in Google Map, right? You cannot have a clear view of the roof, of the rooftop, right? You cannot tell how many chillers, how many green facade. You cannot tell the details, right? The elements, the system being installed at the rooftop, and then you can see at the street level because of the MMS. Right, available. So all sort of the details of the view at street level, including the landscape, waterworks, shops, shop fronts, roads, etc., can be seen clearly and identified individually. Right. So this is the difference. Right. So just move on now. So I just explained the data. Right. The type of data, classification. Important. Now, how to make this? I repeat this slide. So just we capture data side and then the application side. So the benefits, of course, is to facilitate applications, facilitate different users, and trigger collaboration, co-creation, etc. So this is sort of the roadmap or the plan of Hong Kong. So with the data, with the applications, and then government will no longer or aim not to work too much silo, right? More collaborations, and then moving forward to sort of plan or the ultimate aim of a better built environment. So let's move to what actually being requested by the government now. Now, this is sort of the technical circular. Maybe some of you already are aware of that on the project execution from the Development Bureau of Hong Kong. Now, this is at building and infrastructure level. And again, I believe that some of the applications at your end have been developed, right, through projects. Now, here is a BIM, right? When we have the BIM model available at building or infrastructure level, different applications or user cases at different stages, right, can be realized. And basically, this is a list for government projects, right, in Hong Kong, especially infrastructure project in Hong Kong. O is optional, M is compulsory, mandatory. So on the right-hand side, basically, is the update version last year, end of last year. So just take a look at the right-hand side. A lot of applications have become mandatory comparing to the older version. So a lot of M here, meaning we need to realize it and execute it through our project, especially the civil engineering project. So you can see the applications from design stage, feasibility stage, from planning to design and construction. And then in the paragraph, actually, is also hints us or sort of pave the path of using the data to future operation. So you can see different applications like design, authoring, design reviews, visualizations and review, and site analysis. I cannot name everything, but you just have a quick look of what's being requested from the institutions, right, from the government. Now, another example I just quickly show you at the building and infrastructure level what we can do to sort of one types of applications. Now, here's what we did for a private developer in Hong Kong in one of the community development, sort of existing community in Taikoo Place. Of course, we did it right at building and community level. So basically, we make use of them and digitalize and turning the 2D into 3D based on the operational time. And then here is, of course, the real-time data, the dynamics data, and through the dashboard to collect data from different systems. Here's the environmental control HVAC systems, and show to the facility management team to support them to do energy analysis, energy profile, and then of course on the data management side, we have different types of catalog and different systems, etc. And more importantly, basically, here is the optimization of energy through the big data analytics. Right, you know, of what we can do at building level, right? And then let's move on to application at city level, right? There are more potential to make use of this data to realize different types of applications at city level. As I mentioned again, I use Hong Kong as an example. Hong Kong, given the geodata store already set up, and we can make use of this data, and then also to demonstrate the usefulness of this data through applications. So here, I would like to show you a little bit more detail about what can be done, right? So this is an example of what we did for the Urban Bureau, right? Steered by Planning Department, that on the common data infrastructure. So this is the umbrella set out by the Urban Bureau, they call it CSDI, and then here is the platform for applications. So we have three main types of applications from planning and land use. The second is and the landscape environment and conservation. So the concept, what I just explained, we have from different, we put all the solutions into a single platform. And I will show you in a minute a video. I explain to you one by one these applications so you can have more understanding of what can be realized. Right now, this is this is the project, and we start by producing 10 prototypes applications from 30 candidates through the four categories, and then at the end we build up 10 numbers of applications, and then the first three we call it sort of quick win. That's the government departments, they think they're important, and they can sort of kind of a no-brainer, they need to do it and demonstrate it. So the first one is on GIC facilities and open data analysis. GIC in Hong Kong, meaning government institution and community facilities, basically it's public facilities from the government, and together with the open space analysis. So given the growing or declining populations in various districts in Hong Kong, how do we link up these population change to the provisions of public facilities? So this is the purpose of this user cases. This user case. So basically here you can see by district or by OZP in a given district, right? We can analyze how many facilities have been included in existing district. And then with the demographic data available, we can analyze schools, kindergartens, those typical type of GIC facilities. And then, for example, analyze the walking distance. So when I have, say here, I set up 500 meters walking distance, and then we can far to walk through within the 500 meters how many related facilities is included for a particular or respective group of people. So this is sort of the first applications, and then with the GIC, and then we understand sort of the future provisions of facilities, and then secondly, the big questions in Hong Kong is, can we find appropriate space or area to provide these facilities, right? Lack of space, lack of land is a key issue in Hong Kong. So that's why even we identify the need, where do we put the facilities? So that's why we have the second site search. Basically, it's a territorial level. Usually the government, the respective government department will request land. For example, the social welfare department, they need to build elderly home, they need to build different types of welfare facilities. So they need to find land, for example, or area, vacant areas, vacant space. So they can, through this platform, which district, where is the potential land space, right, that are vacant. So they can, find and search this land, the available land, right, and visualize and generate the report from the site search results. And of course, they can set different selection criteria, right? For example, within a meter or distance, there must be stop, for example, and also the inclination, etc., etc. Yes, the land identified the surrounding area. We test out 4 key. So here we the vegetation cover and vegetation density. So you can tell the biomass, of each zone, basically representing the bulk of green, including trees and shrubs, right? And then we further analyze the green space factor, including both green and blue infrastructure. So to give more data in terms of the green density and green provisions of the respective area. So we try to make use of these data and then make it more detailed. For example, in the old days, you cannot tell sort of the types of trees or shrubs. And well, basically the tree management, the TMO, they got all the data. But now we just put it in the same platform. And then, as I mentioned, each tree can be individualized, a single object. So we can actually make use of this individual object to make information of information. So basically a lot of attributes, within this individual objects. And then we make use of this to analyze, the shading analysis and correlate also with the carbon analysis, because for each tree, the carbon absorption is different because of its size and dimension. So basically here, because of the available tree information, we can do a lot of correlated analysis and play around the sensitivity by adding more trees or deleting the tree. What would be the effects? And we see a lot of potentials because the department, they can correlate the trees with different parameters like air quality, like transport, like people's health, etc., etc. All right, now explain other prototypes for you. You can link it up with your actual projects. So it's not necessarily district level, but also site level. It can also be similarly applied. For example, the trees, the green measures that I just explained. The land use monitoring and analytics is another key use because now a lot of government departments, they just have their drones flying through the territory to get more images for the respective works and checking. So here we demonstrate by making use of AI, and given the photo data that the government passed to us. Here is the brownfield in Hong Kong. In Hong Kong, within the brownfield, there are different types of activities, like shown here. There's some construction activities, logistic activities, waste recycling. So there are different types of trades within the brownfield area. And the government, they need to, in the old days, or conventionally, they need to send surveyors, technicians, to check these areas, right? And then now, because of the photos and the aerial images taken, and then we can identify the types of, brownfield land being used in the respective area, as well as because of the satellite images, we can compare the change of land use, right? To help, for example, EPD, they need to identify illegal dumping, right? There's some illegal dumpings of construction waste in some remote areas in the new territories, tree loggings, right? Illegal cutting of trees, or removal of waterworks or water bodies. So we can see the difference between and after through a more frequent approach of getting images, right? And then another examples in the planning and land use is about generate the building mass, right, with different building or planning parameters for a district, right? So if you have an urban renewal project, like here is one of the new development area in Hong Kong. So we play around different building mass and topography with different planning parameters like height limitations, like site area, plot ratio, etc., etc. So the related client can visualize as well as to understand the sensitivity between different planning parameters. Right. Let's move on. Now, within the planning, another key concern is about connectivity. So people are more concerned about walkability and safety, and then because of green transport, more pedestrian-friendly environment needs to be examined and suggested in the new plan. So this is a tool for the client to understand the walkability within the district or within the zone that we are in, that we're analyzing. So we put a more detailed city model together with them, and you see individual tree, individual benches in the park. So you see from a more macro view, the overall central area in Hong Kong, we can analyze sort of, for example, from the central MTR station deep underground, how many steps, for example, from deep station MTR to the destination in a high-rise building, for example. So the elderly people can understand how they actually walk. Is it convenient? Is it safe? Is there any shelter along the path, etc., etc.? So this is a tool for analyzing, these different key parameters like safety, environmental friendliness, and convenience for walking, etc., etc. On walkability. And so I move on, and another application is more on the engineering side, on the infrastructure engineering. One key use, and a lot of government departments, they need it very they need to have this to actually coordinate underground conditions. And if they want to develop the underground space, they need to understand the underground conditions. Like here, even now in Hong Kong, the data basically is a 2D. Even 2D is not digitalized. So we need to digitalize the 2D data underground and to show the utilities and also the piles you see. And then here is one key area in Hong Kong, in the Kowloon Park. The government is going to develop the underground land use. So they need to understand the physical barriers, the underground conditions, and the underground you see basically is the density underground. So in different colors, and doing crash analysis underground and see where are the rooms of putting different uses underground if they need to plan ahead, a common underground space use. So this is another applications, right? And then right, and now this is sort of, I think the number 8 applications is called code compliance checking, right? So during design process, we need to go through a lot of department like the BD, right, for building project. We need to go through the building departments and we need to submit the BD plans, right, to fire service department, to building department, etc., etc. So here, basically, we demonstrate through the full hard coding and also through AI. We demonstrate a few checking exercise. Here for example, we check the plan whether it's satisfied with the usable floor areas. We check whether the exit sign and sprinkler provisions under the fire regulations is satisfied or not by making use of the BIM model. So this is I think should be enough for you at this moment to let you sort of understand the use of the 3D data. So you can see as a whole, we have the 3D city data as a backdrop, and also combined with different data sets to further trigger applications for different end users. So this is something that we are now doing for the city government. And I have a couple of few slides, and then I can move on to the question and answer. Now, as I mentioned, the interconnectivity is very important, for these applications. So from a client's perspective, they spend a lot of money, to collect the data and to develop different applications. So they need to understand a little bit more the synergy or the sort of the interlinkages between these applications. So for example, here, we have the scenario planning, right? So we have this one applications on generate different building mass, different types of development for the new development area, of this site. And then other applications should be integrated, right, at the end. Say, for example, the underground utilities should be integrated within this NDA, right, for this project, as well as the walkability, and also the tree and green analysis should be all in and integrate into one, integrate into one bigger applications. So this is something that should be further explored. When we have the individual applications developed, then we can move on to further explore the interconnectivities and how do we link up, different applications to generate more useful data. All right, so this is sort of the last slide. So a lot of friends, in the industry, how do we realize it in the actual project? So I just give you a very simple sort of a sample that how do we normally help the client. Some of the clients are architects because obviously architects leading the building projects or represent the clients to spearhead all the things. Now if we need to sort of implement the digital twin that I just showed to you, both at district and city level, sort of the typical stages would include, as you see here in the middle column, stage 1 to 3, and across from master plan and then design, construction and operation. And on the right hand side is the key task that what we need to do. And of course, we cannot do something arbitrary. So we need to understand, of course, in task 1, understand and align with the project vision, and understand in different cities or different sort of political regime, what are the sort of the requirements in the first place. And then we engage different stakeholders from government and also, you know, the clients' teams, et cetera, to understand the needs. So basically, it's a bottom-up end user analysis. And then moving on to the platform. So what does it, what will it look like for the platform? What would be the functions of the typical platform? And then what are the user cases based on the stakeholder and also the sort of desktop study? So in task 4. And then within, you can see within the master plan and design stage, what we need to do is to set up the platform. And then we try to pilot test. Here's a proof of concept or pilot test, some application demonstrations. Say, for example, 5 POCs in the design stage, what we can do, similar to what I just showed you, like planning applications, like design analysis, etc., etc. So we can pick the appropriate POCs for demonstration in the design and planning stage. And then moving on to construction stage, because of more data is accumulated. So we can further scale up the platform because of where we need to store, we need to manage more data. So we need to scale up the platform with more data. And then with more data, with and along with more data, we can further develop applications for the respective stage, i.e. here is the construction stage, right? And then similarly apply in operational stage, when we have the platform set up, basically is a one-stop, sort of one single platform to gather all the data and then to sort of facilitate the applications development. So it's a very simple explanation of how we, you know, a single project. So given the time, I stop here. Thank you very much. And I should hand over to Yvonne. You can in charge of the Q&A. Thank you.
Hello. Yeah, thanks, Bruce, for the very informative sharing about the data. Before open to the Q&A sections, I would like, the members of two institute, if you have question, you can type it in the chat room, and then we will share with Bruce, and then Bruce will respond to question in the coming 15 minutes. So okay, so Bruce, I tried to Google it. In the internet, it seems the Hong Kong Geodata Store already open to the public, right?
Yes, correct.
But how about the other one? The Common Spatial Data Infrastructure. It seems not open yet, right?
The Geodata Store basically has been opened. The alpha version is available, so people can go there, but it has been classified by different classes, different sectors. So basically, you can download the data for use. This is one of the sources. Another, of course, you can go to data.gov.hk. This is another library that you can get.
Yes. So how about the other one? Does the other one, the Common Spatial Data Infrastructure, is also open already?
Yes. The Geodata Store basically is under the umbrella of CSDI. Common Spatial Data Infrastructure. Yeah. So the brand name, they call it Common Spatial Data Infrastructure. Okay. And then there's sort of two streams. One stream is on data, another stream is on application. On the data side, the Geodata Store already available.
It seems quite a lot of data have to be input for the use. How many years for the preparation, to have such big data for the people to search? 4 years or several years?
You mean how to prepare? How long?
Yes, for how long for preparing such system for the use?
How many years have been used to set up the data store? Is it your question? Basically, it's a transformation of the data that has been that have been collected and prepared by different departments. So the mechanism is that the Lands Department, for example, the geodata stores host, they set up the platform, and then they encourage department to share the data. They also apart from asking them to share the data, they also set out the standard, sort of the type of data, the standard of the data, to ensure other departments, when they share the data, they can share something usable in the formats their company use. So I would say the data have been here and there for many years. It's just a matter of collecting and collating this data in a single platform.
Okay, thanks. Bruce, can you see the chat room? The question?
Yeah, I can see. Yes.
You want me to read it to you, or you can respond to the one from Arup? There's one question for you. It said, do you know whether the government has the plan to incorporate the geological model or geotechnical data from, I can't see it,
from CDD into the CSDI?
Yeah, CSDI, yeah.
This one, if you recall, if you can see the one of the applications we developed for the underground, we got the pile data and also the piling data from BD. About the geological data, I think CDD, they should have. It's just a matter of whether they put it in CSDI or not. For this, usually at project level we can get it, but I'm not sure whether CDD will open it for CSDI.
Okay. Yes. There's another question from our member, Mary. He asked, what kind of dynamic data from social media is obtained and used? And how is it such data obtained and used? Which application are data from social media usually for? Maybe.
Well, usually, we had a project years ago for Kowloon East of the Hong Kong's forward.
So
Yes. Hello, hello.
You can continue, yeah.
Yes, we once explored by making use of social media data to understand the opinions of stakeholders for the smart city development in Kowloon East. At the end, we didn't use the social media data because there are not too much opinions being put in the Facebook or Instagram, etc., etc. But technology-wise, we explore this and try to make use of some samples. Basically, it's a search of keywordings and frequent of those wordings or text, and relate it to different topics on smart city. But basically, this is in other countries, when social media is closely monitored, and the sharing, the tags are being analyzed for different purposes. It's not new technology. It's just a matter of whether it can achieve the objective or not.
Okay. Yeah.
Yeah.
Hi, Bruce. There's another question from AAM, Jimmy's. The question is, Jimmy noticed the chart at the beginning of your presentation. The countries sit either on the spectrum. The question is, why do you think these countries have different priorities?
Well, in theory, there are sort of two schools of thoughts. One is data-based, Another is application-based. So I assume you mentioned about the y-axis and x-axis. Some cities are more concerned about data production. Some cities are more about the applications, right? To demonstrate applications, to actually to do something usable for different departments or end users, or trigger research in the between academia and government and industry. So it's a matter of chicken and egg. Some government like Hong Kong and Singapore, they concern both. The role, like Singapore and Hong Kong government, they're the facilitator. They just produce data, make it available for the public, and share it and open it. And then the industry and the academia, they pick it up. And then when they're preparing data, of course, they need to seek advice from the users, i.e. the academia, industry, and general public, of course, to understand the requirements of the data. Like, for example, the road department, they need the accuracy of the road surface in a few centimeters accuracy, right? In order for them to monitor the conditions of the road surface, to monitor the cracks. It's even harder for the airport authority, you know, for the one-way. They even need a more accurate, finer accuracy in order to check the cracks of the one-way or the road networks. So it depends on, it really depends on the user requirements. So it becomes a matter of chicken and egg. We need to understand the application side. We need to, and then through the applications to produce a more relevant, actionable data for the users. So kind of, I would say many governments are now not only producing the data, but also through the data to trigger applications, because they need to justify the value of data. They spend a lot of money, you know. It's not cheap. They use helicopter resources, drones, and road surface MMS to collect the data, to capture data and integrate them together to produce the updated 3D model. So why do they do that? They need to justify. They need to get money from the top government, and then they need to explain the value. So that's why they need to consider both at the end or at some point.
Bruce, there are two more questions. One from Arup. Anyway, are the SPL 3D models of territory existing tunnel, let me see, or other structure like foundations in Hong Kong open to download, so we may incorporate into our project models?
So I think you need to, depends on the purpose of how you use the data, but I don't think one will be opened quickly because of sensitive information. And of course, you can individually ask BD if there's a lead. Yeah.
Okay.
But there's not sort of open for everybody to download, right?
Okay. Okay. I think this one is the last one. Okay. It's from Macau. Is Jimmy also again. So Jimmy said, do you think the use of AI is a double-edged sword? And it can certainly be used to solve problems, but also it can shape human behavior. Is there some sort of international standard or regulations to limit the use of collected data? I mean, as this information could also pose security risk. So what's your opinion?
Yeah, of course. Here we need to always address the privacy and the security risk. But this one, we need to engage maybe a security expert to work on different levels of protections, from network level to software level, to cloud level, to even utility level. So of course, we need to address all this to up to international standard. And then with regards to the standard, EU is more advanced and set up sort of, the pioneer in setting up this data, the privacy or security standard, because of the awareness of the public at their side. So we are following, and we are sort of see how to sort of modify to suit the context here.
Okay, yeah. Really, a last one is from Hong Kong AAM Mary Chan. The question is, the new building usually we have BIM, but for the old building, how can the digital can be done? I mean, they don't have the record plan, so a lot of existing buildings in Hong Kong are old buildings, and then which do not have BIM models and even draw by CAD. So how to have those models?
Okay, two ways. A slower method is that if you can pick up the sort of the 2D map, I mean the 2D drawings, you can sort of draw it again, digitalize it through CAD and then turn it into BIM. But it takes time and it won't be very accurate and very tedious and also labor intensive. So normally we don't use this way. The second way, of course, is quicker, is that you use point cloud scanning. This one slide I show is the internal scanning. Is very cost effective. You can just ask the contractor, say one floor, you can just take around 2 to 3 hours to just walk through the floor and through the scanner. So you have a backpack scanner or you have sort of a mobile scanner, and it's just laser point cloud scan through all the different building interior, and you can instantly get the 3D digital model with accurate reflection of the interior. You can do all the measurement and all the things from the point cloud model. So it can be very quick and cost effective nowadays.
Yeah.
In general, I'll just give you an order of magnitude. Last time I just partnered with a contractor. In average, one building, existing building in Hong Kong in total, 210,000 existing building. I just estimate for the government. For example, now one building, roughly speaking, around 20 to 30K. Yeah, you can scan one. Yeah.
Okay, yeah.
So it's very cost effective.
I think time's up, and then yeah, thanks Bruce for the sharing. And Bruce, can you I want to share a screen for.
Yeah, I just quit.
Yes. We just shared a thank you, short of appreciation to you, and then because right now in Zoom, can you see it?
Oh yes, I can see it. Thank you very much.
Yes, yeah. We cannot hand it by hand. Yeah, but also we also have a booklet from Hong Kong IA. We will post to you. Yes.
Everything is virtual now because of the online.
Thank you very much.
So,
fully understand.
We will check that booklet together with the appreciation certificate to you.
Yeah.
Thanks a lot.
Thank you very much indeed for your in-depth sharing.
Yes.
On big data. Thank you.
Thank you. Yeah.
Thanks a lot.
Thanks all the members for spending the time, and also thanks Bruce again. So if you have further questions, it's welcome to email to us, and then we can pass to Bruce. So it's okay. That's the time for today, and then thanks very much. So see you in the next seminar. Okay. Bye bye.
Good evening. Bye bye.
Bye bye.
Bye bye. Bye bye.
Bye bye.